Today's topic is going to be algebraic expressions. This should be a review for everybody as you've been building upon these concepts since sixth grade. What is an algebraic expression? Plain and simple, it is made up of variables and constants that contains algebraic operations, such as add, subtract, multiply, divide, but we also now have exponents. You might have brackets. Each expression is made up of terms, and that shows the value of something. The reason we create an expression is to give it value. So for example, 2 plus 3 is an expression. 5x minus 9 is an expression. 3 minus x over 2 is an expression, and then negative 18, that's considered a constant. So let's go a little further and talk about what is a variable, what are terms, and what are constants. Variables, plain and simple, is something we don't know. We are going to work with a lot of variables this school year. It's just an unknown quantity, and we use a single letter to represent that unknown. Terms are numbers, variables, or a product or quotient of numbers and variables. So when we put it together. So variables that are added in an expression are what we call terms. Okay. So we're going to go more into detail about how to classify terms. A constant is simply a term that does not have a variable part. Last one is a coefficient, and you're going to hear this word a lot. The coefficient of a term is the number that's being multiplied or divided to a variable. Okay? So let's take a look. We have 3x plus 8y minus 4. Well, what are the variables here? Our variables are x and y. Now our terms, we have to be specific. This has 3 terms: 3x, 8y, and negative 4. Many of you are sitting there and saying, well, that's minus 4. A minus is a negative. The sign in front of the number or term goes with what's behind it. So when we identify our terms, if one of them is a negative, we have to state the negative with it. Constants in this one is negative 4. Now we have 2 coefficients. We have a coefficient of 3 and a coefficient of 8. They are both the number part of the term. Okay, so let's take our vocabulary here. What are the terms in the expression? Well, let's look at this. How many terms are there in this one? This one has 3 terms. You have x squared, negative 3x, and 1. So let's look at this left side here. What is the constant term in the expression? In this one expression, 3q squared minus 7q plus 11, our constant is 11. It's the one without a variable. Now, if I wanted to go focus on coefficients, let's particularly look at this expression. I want to look at the variable of p, and I want to know what the coefficient of p is. That's right. If you said negative 23, you are correct. Okay, so we're going to build on this concept. As we go through, on this page of notes, you see the 4 box. You've got add, subtract, multiply, divide. Throughout the school year and throughout this section, you're going to come across numbers that signal a certain operation. Jot it down, add to it as we go. So let's look at the first one. 9 increased by a number. What do you think that will look like? Take a moment, pause, write down what you think that answer would be. Okay? Well, if you said increase is add, you are correct. It means I have 9 and I increase it by n. Now, a lot of you might have made up a number. If you're ever given something that says by a number, that's something we don't know. So again, based off our definitions, we use a variable. You can't just make up a number. Okay, so let's try the next one. 14 decreased by a number. Pause and try and write what you think it might be. Okay, let's see. Did you get 14 minus n? Good job. So most of you probably have read ahead, and that's great, but be careful with this one. 7 less than a number. Write down what you think this would be. So how many of you wrote n minus 7? Probably a few of you, but most of you probably wrote 7 minus n, meaning you put the 7 first. If you did that, it is wrong. The order of subtraction matters. When you have the words less than, that's a flip word. Fewer than, subtracted from, those are what I call flip words. Meaning the 7, since it's before the subtraction phrase, actually has to go after the subtraction sign. You actually flip their order. And we're going to get into that, and you're going to see this all school year and in geometry and so on. So let's try this last one. The product of 9 and a number. I'm hoping most of you at this point have realized product of means to multiply. But we are in algebra. So if we're dealing with a number and a variable, we write them right next to each other. No multiplication signs, and we don't ever want to use an x for multiplication. That is out the door, because sometimes x is our variable, okay? So when we're dealing with a number and a variable for multiplication, we write it just like we did here, 9n. It's going to signal our brain that that means to multiply, okay? Let's take a look at creating an expression from a real world situation. I have a rule of 3. Read every word problem 3 times before you even pick up a pencil. Emmanuel has 745 pictures in his phone. His memory's getting full, so he starts deleting 20 pictures every day. Define each variable and write an algebraic expression to describe the number of pictures left on his phone after any given number of days. Okay, so there's a lot in there, but let's go back through and let's read it again. Okay, Emmanuel has 745 pictures in his phone. His memory is getting full, so he starts to delete 20 pictures every day. All right. Now it says define each variable and write an algebraic expression to describe the number of pictures left on his phone. So right now, my first step is start with what we call a let statement. This defines your variable. It allows you to keep track of what you're searching for. Okay. So what do we need to know? We are looking for the number of pictures left on his phone after any given number of days. What don't we know? Well, we don't know the number of days. So we're going to say D equals number of days. Okay. If we go back through and we look, there are 745 pictures starting on his phone. That's great. But what does he do? Well, he deletes 20 pictures every day, okay? So when you're saying 20 pictures per day, every day, it's 20, 20, 20, 20. What's a way we write repeated of the same number? Well, that's multiplication. But what do I do with those two numbers? Remember, what is the action that he's actually doing? He's deleting. So if he's deleting, that's subtraction. You now have your expression. Plain and simple. There it is. Okay, so this next one is a little more detailed and it requires a little bit extra attention, I would say. Alex and Leandro purchased 2 matinee movie tickets. A matinee ticket costs $6.50, a drink costs $5.50, and a bag of popcorn costs $6. Define each variable and write an algebraic expression to describe how much they spend based on the number of drinks and bags of popcorn they buy. Identify the parts of the expression by underlining coefficient, circling constant, and drawing a box around the variables. Wow, there's a lot there. So let's go back. First, it says define each variable and write an algebraic expression to describe how much they spend. Okay, so let's focus right there. I'm defining a variable, right? Well, what do I know? Okay, we're defining it based off what they buy as far as drinks and as far as popcorn. But they had to get into the movie, so look what else they bought. They bought 2 matinee tickets. Okay, I know what a matinee ticket costs me. Okay, that cost me $6.50. So we can say that $6.50 times 2, I already know they're spending $13. They have to spend $13 to get into the movie theater, okay? So let's go back. A drink costs $5.50. Well, do we know how many drinks they purchased? Well, they might have done one each, but someone could have gotten a Coke and an icy. Or someone could have gotten a water bottle and an icy. We don't know how many different drinks they bought. So we have to say D is the number of drinks purchased. Remember, when we're repeating something, okay, we use multiplication. And it was $5.50 times however many drinks they bought. Well, what else did they spend possibly? They probably spent money on popcorn. You go to a movie, you're going to buy popcorn. Do we know how much popcorn they bought? They could have bought 1 to share. They could have bought 2. They could have bought something for a friend that they met there. So we don't know the number of bags of popcorn purchased. So I'm going to say P is the number of bags of popcorn. So while you might not want to write a let statement, it's super important to write it in one. This problem requires it. So there's 2 points right there. But on another end, it allows you to figure out what numbers go with what variables. For example, I have to do 6 times P. I want to make sure that what I'm solving for one of these variables down the road, that I know which one it's referring to. Was that the number of drinks? Was that the number of popcorn? By writing these let statements, that allows you to do that. Okay? All right, so I've done most of the legwork. Now, when I go to the movies and I spend, how would I find the total? Right, I add them all together. So there's my expression. I've defined each variable and I've written an algebraic expression. So most of you would say, okay, I'm done. I'm done with the problem. I can move on. But you're not, because it said underline the coefficients, okay? So you need to go look at your expression and put a line underneath the coefficients. Okay, what else did it say to do? Right, it said to circle the constant. So right now, go circle the constant. Which one there is your constant? Remember, a constant has no variable part. 13. You're not done yet, because it asks you to draw a box around the variables. Okay, this one should be straightforward. We already defined them. There you go. You should have a box around D and a box around P. So feel free to go back, rewatch this movie. Make sure your notes are completely filled in and you feel confident with these vocabulary terms because we're going to use them in class the rest of this section as well as moving forward throughout the year.